Hello and welcome to Algebra 2, the second part of 8.4 logarithmic functions. And in this video we're going to investigate graphing log functions. The first thing to remember is that an inverse, a graph of an inverse, reflects over the line y equals x. And so if a logarithm is the inverse of a variable as an exponent, which, if you recall, then from 8.1 and 8.2 are our exponential growth and exponential decay functions. These graphs are going to be inverses of those graphs. So, for instance, if we graphed exponential growth, let's do a positive a in the front, so it's going to look something like that. And then let's put in y to the x. And so its inverse, which is going to be the log function, is actually going to then come up like that. Okay, so these graphs are going to look like this green one here, and they're going to come up. And in fact, I drew that wrong because it should not have come to that side of the y-axis, but it's going to have that same shape. It's going to come down like this, still with an asymptote. This time, though, it's going to have a vertical asymptote and not a horizontal asymptote. Alright, so we have the graph of y equals log base b of x minus h plus k. So remember, we still have these shifts. They're the same shifts for parabolas, for absolute values, exponential growth, decay, cube roots. It's all the same shifts. If it's in this form, it has those shifts. Alright, so we do have a vertical asymptote, and that vertical asymptote is going to be at x equals h, so take note of that. The domain is going to be x is greater than h because we're graphing to the right of that, and the range is going to be all real numbers because these are going to go up and down forever. If b is greater than 1, the graph moves up to the right, so meaning it's going to look like that. And if b is between 0 and 1, the graph moves down to the right, meaning it's going to be reflected like that. Alright, so let's graph y equals log base a half of x plus 4. And so just like before, if we look at our parent graph, this part right here is our parent graph, and then what we can do is we can shift all of them up 4. And looking at the form you just wrote down, the log base b of x minus h plus k. So our h in this case is going to be 0 because the x is just by itself. There's nothing with that x there. And so we are going to have a vertical asymptote at 0. So there's my vertical asymptote. And what you can still do, do your parent graph and then shift up 4. And so if you want to organize in a table, that's an excellent way to organize things. But what we can do to make it a little easier is looking at just that parent graph. Let's go ahead and write it in exponential form. And so this would be 1/2 to the y power equals x. Okay, so remember that's how you go back and forth between log form and exponential form. And so then we can kind of, let's pick some x's. So let's pick, that's a y by the way, let's pick a 4th. So if x is a 4th, what does y have to be for x to be a 4th? Y would have to be 2, and then we're going to add our 4 to it, so that's how we get 6. So, or two ways you can do this. You can go ahead and plot 1/4, 2, and then come in later and add 4. That's what we've been doing. 4, putting it up there. Okay, or if you want to just go ahead and add the 4 to begin with. So, what x's, so if we just did like an 1/8, then what's y? Y is 3. So at an 1/8, we're at 3 plus 4 would be 7. And the closer we get to this asymptote, the higher up we're going to go here. So we want to try, would be up there, We want to try to go out to the right. So if we put in 2, so that flipped the 2 to the top, so y would have to be a -1. So we're looking at 2. And if we add 4 to that, that would be 3. So we can either graph 2, 1, sorry, 2, -1. That would be the parent graph, or we can shift it by moving it up 4. Okay. What about if we set it equal to 4? So then y would have to be -2, because not only did it flip to the top, but it squared it. So then we're looking at 4, -2, and I know I can't count, so sorry. Let's try again. 4, -2, and then if we want to shift that up, we're going to move it up 4, so it would be at 4, +2. All right. And so what this is going to look like then, so it's going to come down this asymptote and come this way. It is going to go down forever. Like it's going to continue to go down on the y values forever. So your domain is x's that are greater than or equal to 0, and your range is going to be all real numbers because it does go up and down forever. Okay, let's look at one more. All right, and I would start by doing, let's write exponential form, so it's 3 to the y equals x minus 2. All right, and so here's my table. And this time, if I do my parent graph, which is just this part, so in fact, let's leave that 2 out of our equation here. If we do our parent graph, then what we're going to do is we're going to shift everything right 2. All right. And so, by the way, that is my vertical asymptote, because remember it's x is greater than, or x equals h is your asymptote. So there is my asymptote. So then we're going to come up with some values here, and they have to be x's that are greater than 2. So what happens then if I put in 3? What's y? Y is 1. So we get the point 3, 1. And then what I'm going to do is I'm going to move that point right 2. So my real point would be 5, 1. And this might be a little harder to keep track of in a table, but we'll try here. So what if I make that equal to 9? Then y has to equal 2. And so notice I'm purposely picking points that it's easier for me to figure these out. So then that point would be 9, 2, in which case then I'm going to shift that to the right 2 and to be like 11, 2. Okay, so what happens if I get closer to my asymptote here? Let's put in x as a third, because I'm going to shift, so this should work. So what would y have to be? Y is -1. So this starts out as a third -1, which would be there, but then I'm going to shift it. There we go. Now what you're going to get at the end is this one's going to come around like that. There we go. All right, domain are the x's greater than or equal to 2. Range is all real numbers. All right, so that's what I got for you. Now, several things to keep in mind. You know, I was picking these x's on purpose because they were giving me nice y values. You know, there are ways to solve for those x's, but until we get there, if you can choose nice x's, it will make your life a little easier. And then again, sticking with that parent graph and shifting it, I think is going to be your best bet. All right, let me know if you have any questions, and we'll see you in class.